Hi, welcome back. Today we are going to discuss about the flip-flops. So these are the certain applications of flip-flop. So the flip-flop which can it can be able to use it for the data storage, registers, counters, and for the memory elements. Flip-flop. A circuit that has two stable states is treated as a flip-flop. So in a flip-flop, it has a two stable state. One is nothing but 0 and another one is nothing but 1. So here, the flip-flop and the latches are used for the data storage. If you are storing a certain data in a flip-flop, it can be stored for many years. It won't raise until many years. Okay, so it can be used in the olden days. So in a single flip-flop, we can able to store only one bit, that may be either 0 or it may be 1. So not able to store many data. Okay, if we are having only one flip-flop, we can able to store only one bit, that may be either 0 or 1. Suppose if you want to store more than one, if you want to store 4 bits, means you need 4 flip-flops. So based on that, you can increase the number of flip-flops. Okay, so there are totally 4 types of flip-flops are there. One is nothing but SR flip-flop and JK flip-flop and D flip-flop and T flip-flop. So these are the different types of flip-flops. So SR flip-flop. So here this is an SR flip-flop. So an SR flip-flop, here we are designed the circuit by using the 4 NAND gates. We are using the 4 NAND gates. So here there are 2 input. One is nothing but S and another one is nothing but R. So there are 2 input, S input and R input. So it may be either 0 0 or 0 1 or 1 0 or 1 1. These are the possible inputs for the SR flip-flop, and the output will be Q and the output will be Q. Okay, so this will be Q and this will be Q bar. So this is the opposite to the Q. Okay, so now at this case, if the both the input S and R, if the both inputs are 0, so the output will be same as previous state. If the previous output is 0, the present output is also 0. If the previous output is 1, the present output is also 1. So it won't change. But if you go for S is 0 and R is 1, you are getting the present output of 0. Whether the previous output is 0 or 1, whatever it may be, but the present output is 0. If S is 0, R is 1, you are getting the output as 0. Okay, and for SR, the S is 1 and R is 0, you are getting the present output is 1. But if the both the input is 1 1, so that is the present output, it is nothing but toggle. So that is nothing but undetermined. That is nothing but undetermined. If the Q is 0, the Q bar will be 1, should be 1, and if the Q is 1, the Q bar should be 0. But in this case, if both will be 0 or it may be 1, so this is nothing but an undetermined state. So that here they are marked as question mark. So in order to eliminate these certain issues in the SR flip-flop, we are moving into the JK flip-flop. So in JK flip-flop, so here that can be eliminated. If J is 1 and K is 1, so you are getting the toggle. You are getting the output as toggle. The toggle, what is a toggle? Okay, so whether you are getting the output 0, if the input 0 or 1, you are getting, okay, if the previous output is 0, here you are getting the 1. If the previous output is 1, and you are getting the toggle. So every time the output is always changing, but you are getting the output, but it is changing with respect to the previous output. Okay, previous output. So that is nothing but JK flip-flop. So in SR and JK flip-flop, there are 2 input. So but here we are reducing the two input into single input. So here the T is nothing but toggle. So it is the it is a simple reduction of a JK flip-flop. So here both J and K will be shorted. So here instead of two input, here it has only one input, the one input which is given into the two gates. So instead of two input, here we are using only one input, so that the number of possible combination can be reduced. The number of possible combination can be reduced. So this is the same output as JK flip-flop, and this is nothing but D flip-flop. So D flip-flop is the modification of SR flip-flop. So here also SR flip-flop having the two input, but here having one flip-flop, only one input, that is nothing but D. D it represents the delay, because the output is gets somewhat delay time. But instead of only one input, but here the input which is given is directly goes here, but here which is opposite, it will be inverted and it will be given into the another gate. So we are using the NOT gate. So but what is the output which you are given the J and K, the same output will be derived in the D flip-flop. And this is an assessment. Mode 12 counter need 3 flip-flop, 4 flip-flop, 12 flip-flop, 11 flip-flop. So the answer is 4 flip-flop, because you can go for the 4. The flip-flop is based on the 1, 2, 4 and 8. So if you are using the 3 flip-flop, so the possible is 4 plus 2 6, 6 plus 1 7. You are getting only 7. But here we need 12. So 12 means if we are using the 8 plus 4, you are getting the 12. 8 4 is 12. 12 plus 2 14. 14 plus 1 15. Up to 15 you can use above 7, and below 15 you can use 4 flip-flops. So these are the few references. Thank you.